In this video, we're going to take a look at positive inducible transcriptional regulation. Our body contains nearly 100 different cell types. Even though they all contain the same DNA, due to gene regulation, they activate different genes for each of these cells so they are able to complete their specialized jobs. Transcriptional regulation is means by which a cell regulates DNA to RNA transcription. You could think of it as monitoring gene expression activity. Though there are multiple modes of regulation on this pathway, we're going to focus on positive inducible transcriptional regulation. If I asked you to figure out if a gene is off or on based on the word positive, chances are you'd say it's on. Likewise, if we think of a gene being induced, we'd say that it's on. While this is halfway correct, as this describes the final state of the gene, genes toggle between being on and off, and when a gene is positively regulated, it began in the off state, and something happened to turn it on. This process isn't permanent, as if it stayed on and allowed RNA to transcribe continuously, we'd have the weirdest occurrences, like our eyes, cells coding and producing stomach acid. This is the point of specialization. Now we're going to take a closer look at this process. When we speak in terms of positive, this is based on a protein binding the DNA. This protein turns on or activates the gene, so let's refer to it as our activator. Referring to our other term, inducible, this explains if a small molecule, let's call it our effector, binds to said protein or our activator. The goal of this system is to get RNA polymerase to bind to the promoter site on the DNA so transcription can take place. So from the beginning, starting with our effector, it binds to the activator and changes its shape so it can properly bind to the operator located on the DNA strand. Our operator site is a group of genes whose information is copied by RNA polymerase onto a single strand of RNA, where it is then read by ribosomes and converted into proteins. This increases affinity of RNA polymerase binding to the DNA's promoter site and beginning transcription. So once the activator binds, transcription begins. So personally, I really love games, and one of my favorite games growing up was Pac-Man. I'm sure everyone has played it at least once or knows of it, but the object of this arcade game was for you to control Pac-Man and eat all of the pellets while avoiding the trailing ghosts. So spread across the game board were a few power pellets, which for a short amount of time gave Pac-Man the ability to eat the ghosts and temporarily get them out of his way. And don't quote me on my drawings, I try my best. In a sense of transcription regulation, I see Pac-Man being our activator and the power pellets being our effector. Once the two meet, nothing stands in Pac-Man's way and transcription or pellet consumption continues. Once all the pellets are consumed, the game is over, or in this sense, transcription is complete and turned off, as I mentioned earlier. This is not a continuous process. Then it can begin again. And these are my references.